Lots of engineering mathematics can't be done by hand using a pencil and paper or a hand calculator, so we use computers to do some of the more tedious tasks. One software package that makes those tasks easy is MATLAB. This video introduces the MATLAB interface and some basic tasks like arithmetic operations, defining variables, and saving your work.
When MATLAB is first opened, you see what is called the desktop. The desktop is the primary interface with which a user interacts with MATLAB. At the top of the desktop is a tool strip, which provides direct access to some convenient MATLAB capabilities. I'm going to ignore the tool strip for the most part. Chances are that you can figure out for yourself what you might want to use it for. The current folder window is on the left side of the desktop. This window shows the files and folders that are in MATLAB's current working folder. Keeping track of the current working folder and its contents is very important. Later on, when we're writing programs and accessing data that's on disk, we'll see why this is. The path to the current working folder is shown in this text bar. If you want, you can change the current working folder by clicking on this icon and browsing to the desired location. For example, I can go to a folder named Testing, which is at the root folder of my C drive. We can use the current folder window to create and remove folders. To create a folder, right-click with your mouse button in the current folder window and select New Folder. I'll create a new folder named Temp in the current working folder. To remove a folder, right-click with your mouse on the folder and choose Delete from the resulting menu. This is the workspace window. The workspace is a chunk of computer memory where MATLAB will store the results of any computations, once I actually do some. In the lower right corner of the desktop is the command history window. This window displays the commands that have been executed in MATLAB in the order in which they're executed. Finally, the command window is this big window in the center. MATLAB commands are typed at the command prompt, the two greater than signs here, and are executed by pressing the Enter key on your keyboard. If you're using the student version of MATLAB, you may see the letters EDU just before the command prompt. Don't let these letters bother you. They don't affect execution of any commands that I'll show you.
The previous demo introduced some important terminology, so I want to reiterate some of the terms that you really should remember. MATLAB's environment is the set of files, folders, and variables you're using during your session. The desktop is the interface you use to interact with MATLAB. It's the first window that you see when you open MATLAB. By default, it contains the workspace window, the command history window, and the current folder window, along with the tool strip that allows direct access to some common MATLAB functions. The workspace is a chunk of memory where the results of your calculations are stored. The command window is the most important window on the desktop. Commands executed at the command prompt are the primary way of interacting with MATLAB. The other windows on the desktop are mostly to help you keep track of what you're doing at the command window. In the next demo, I'll perform some operations in the command window, talk about how to save the results of your calculations, and show you how to access MATLAB's help files.
As an example of how to use the command window, let's do a simple mathematical calculation. For example, if I type 2 plus 5 at the command prompt and then press the Enter key on the keyboard, MATLAB performs the operation and calculates the result as 7. The number 7, the result of my command, is now in the workspace. Think of the workspace as a chunk of memory that contains the results of your mathematical operations. In order to keep track of all these numbers, every number in the workspace has to have a name. If you don't specify a name yourself, MATLAB names the value ANS, which is short for answer. We don't have to let MATLAB assign all of our calculation results as ANS. We can provide our own variable names by using the assignment operator, which just happens to look a lot like an equal sign. For example, suppose we want to calculate 4 times 3 and save it as the variable name myvar. We type the variable name, myvar, followed by the assignment operator, an equal sign, and then the mathematical operation whose result we want to call myvar, 4 times 3, and press Enter. One thing to keep in mind is that in most cases, MATLAB commands are not sensitive to spaces in the expressions. To illustrate this, Let's create another variable named myvar2, which is equal to 5 minus 3, but we'll scatter a few spaces surrounding the expression. The result is 2, as we'd expect. The extra spaces don't affect the result. Now let's talk a little bit about the workspace window. The workspace window displays all variables in the workspace. At the moment, the workspace window lists 3 variables, ANS, myvar, and myvar2, just as we'd expect. The values of these variables are also shown. If we want, we can use the workspace window to delete variables from the workspace. Simply select the variable you want to remove and press the delete key on your keyboard. We can also display the value of the variable directly in the command window by typing the variable name in the command window and pressing the enter key. Now let's multiply 3 times 6 and assign it to our variable named myvar. The MATLAB operator for multiplication is the asterisk, so we type myvar equals 3 asterisk 6 at the command window and press enter. As we expect, the result is 18 and is named myvar. However, redefining the variable myvar results in its old value being lost. If we want to get our previous value of myvar back, we would need to redo the original calculation. It's important to keep in mind that MATLAB only keeps the results of a calculation, not the steps used to create the result. Also notice that MATLAB doesn't allow you to go back and edit previous commands. If you need to redo a command, you have to re-execute it at the command prompt. The command history window keeps a list of all the commands you've executed, just in case you need to re-execute a previous command. Notice that all of my previous commands are listed here. If I want to redo the calculation of my first value for myvar, I can drag the command with my mouse to the command window and press the enter key on my keyboard. We could also access previous commands by pressing the up arrow key on your keyboard, which causes the command window itself to display the last command you executed. Successively pressing the up arrow cycles backwards through all the commands you've executed. The workspace can be saved to disk, and we can load saved data back to our workspace. The graphical user interfaces for these actions are the Save Workspace and Import Data icons on the Home tool strip. If you click on Save Workspace, you'll get a dialog box requesting a file name and a save location. Notice that the default file name is matlab.mat and the file is placed in the current working folder, as we can see from the current folder window. The process of importing data using the tool strip is very similar. Finally, let's look at how we can get help in MATLAB. To open the help window, simply click on this icon, the one with the question mark on it, on the tool strip. A separate window opens, which allows you to look at MATLAB's documentation. From the help window, you can browse for topics or search for information on a specific topic or command. Familiarizing yourself with MATLAB's help documentation is time well spent. New users may find much of the information incomprehensible, but it'll become more and more valuable to you as you gain familiarity with MATLAB.
In the previous demo, I performed some calculations and assigned the results of the calculations to variables. In the next couple of slides, I'll provide some more details about MATLAB's arithmetic operators and rules for naming variables. First, I'll present MATLAB's arithmetic operators. Addition and subtraction are performed with the plus and minus signs. There are 2 different multiplication operators, the asterisk symbol and an asterisk symbol with a period in front of it. As shorthand, I call this the undotted operator and this the dotted operator. As long as the operands are scalars, or single numbers, these 2 operators do exactly the same thing. If the operands are arrays or collections of numbers, the dotted and undotted operators do very different things. We'll talk about those differences later after we start using arrays. MATLAB has 4 division operators: slash, dot slash, backslash, and dot backslash. If the values they operate on are scalars, slash does the same thing as dot slash, and backslash does the same thing as dot backslash. The difference between the forward slash and the backward slash is simply which number is being divided by which. The numerator is always on what I'd think of as the uphill side of the slash. 4 slash 2 is 4 divided by 2, while 2 backslash 4 is also 4 divided by 2. Finally, exponentiation is done with the caret symbol or a dot and then the caret symbol. For scalar operands, both of these operators perform identical operations. For arrays, they don't. The order of operations in MATLAB is consistent with what you're probably used to when you use a hand calculator. Exponentiation is done first, multiplication and division are next, and addition and subtraction are last. Within operators of the same rank, operations are done from left to right. Parentheses can be used to modify the precedence since operations in parentheses are performed first. Now I'll do a few examples of these operators. I can multiply 2 times 5 by typing 2 asterisk 5 and pressing enter. I get the same result when I type 2 dot asterisk 5 and press enter. Since the numbers involved are single numbers or scalars, there's no difference in what the two operators do. Later, when we're using arrays, we'll see that there is a difference between the dotted and undotted operators. If I divide 7 by 2 using the slash operator, I get 3.5, as I'd expect. Now I'll divide 7 by 2 using the backslash operator. To do this, type 2 backslash 7. This is still taking the number 7, the number on the uphill side of the operator, and dividing it by 2. 3.5 is still the result. I've just changed the way we do the calculation. As with multiplication, if the operands are scalars, the dot slash operator does the same thing as the slash operator, and the dot backslash operator does the same thing as the backslash operator. To illustrate the exponentiation operators, I'll take the square of 3. I can do this by typing 3 caret 2, which gives us 9, as we'd expect, or by typing 3 dot caret 2, which still gives us 9. The operators do the same thing when the operands are scalars. Finally, let's take a look at some issues with precedence of operations. If I calculate 2 times 3 plus 2 squared, I get 10. 2 squared equals 4 is calculated first. Then 2 times 3 equals 6 is calculated. And finally, the addition, 4 plus 6 equals 10, is done. If I calculate 2 times the quantity 3 plus 2 squared, I get 50. The addition of 2 and 3 is done first now, since it's in parentheses. Then the exponentiation is done, so 5 squared is calculated to get 25. Multiplication is after exponentiation, so the last thing done is to calculate 25 times 2 to get 50. Another example is 6 slash 3 slash 2, which results in 1. Since both operators have the same precedence, they're done left to right. So 6 divided by 3 is 2, and then 2 divided by 2 gives 1. The results of mathematical operations are assigned to variables. Next, I'll go through a brief list of some rules for variable names. Variable names can be at most 63 characters long. You can create variable names with more than 63 characters if you want, but MATLAB will remove any characters after the first 63. Variable names should start with a letter. Other characters can be any combination of letters, numbers, or underscore characters. Variable names cannot contain spaces, punctuation, or mathematical operators. Most special characters, such as %, $, and so on, are not allowed in variable names. One notable exception is the underscore character. Variable names are case sensitive. Capital versus lowercase letters do make a difference. There are several words in MATLAB that have special meaning to MATLAB and can't be used as variable names. MATLAB will display these words if you type the is keyword command at the command prompt and press enter. Finally, there are a number of predefined variables in MATLAB. These variables are created when MATLAB starts. Some common ones are pi, or the ratio of the circumference of a circle to its diameter, I and j, both of which can be used to represent the square root of -1, NaN for not a number, which would be the result of an undefined operation, and INF for infinity, or any number that's too large for MATLAB to represent. I'll start by typing is keyword at the command prompt. None of the words on this list can be used as variable names. For example, if I try to assign the value 4 to a variable named while, MATLAB gives me an error message. A variable named var4 is allowable, so var4 equals 3. But trying to create a variable named 4var results in an error, since variables can't start with a number. Likewise, most special characters and punctuation aren't allowed. For example, my %var equals 3 results in an error, as does my var equals 4. We can't use spaces in our variables, so the variable named my space var isn't allowed. Usually, if people want something that looks like a space in their variable name, they insert an underscore. My underscore var is allowed. MATLAB has a variety of built-in functions. For example, the function sqrt calculates a square root. So sqrt of 2 returns the square root of 2. Function names can be used as variable names, so I can set a variable sqrt equals 3. Then if I try to calculate sqrt of 2, I get an error. If I clear the sqrt variable using the clear command, it reverts back to being a function. Finally, let's take a look at the built-in variable pi. This is also a legitimate variable name, so I can redefine it as pi equals 3. Now, if I multiply pi times 2, I get 6. I've overwritten the built-in value of pi. I can recover the built-in variable by clearing my assigned value. In this video, I introduced some basic MATLAB features and tools. These included file and folder management, some basic arithmetic operations, and saving the contents of the workspace. The concepts from this video will be really useful later when we start using MATLAB's more advanced features.